So our next talk is going to be by Tasso Cocoves of the U.S. Army Corps of Engineers. He's going to be speaking on Recover, Interim Goals and Targets for the Greater Everglades region. Tasso is a biologist for Recover and currently serves as a regional coordinator for the Greater Everglades and Southern Coastal Systems.
Good afternoon, everyone. My name is Tasso Cocoves, and I'm a biologist at the U.S. Army Corps of Engineers and part of the Restoration, Coordination, and Verification, or Recover team for SERP. Today, I will be presenting some of the results from the 2020 SERP Interim Goals and Interim Targets Report for the Greater Everglades region. Before I get started, I wanted to acknowledge the members of the Greater Everglades and Interim Targets teams for making this presentation possible. Why are interim goals and targets important? Produced every 5 years, the IGIT tells us where we're going using planning tools to gauge the likelihood of success of SERP as projects are constructed and operated. It provides a basis for evaluating and reporting progress to policymakers and the public, and it assists in the adaptive management process. For those of you who couldn't make the first presentation of the session, this slide provides some background information. The regional simulation model was used to compare 4 model scenarios using 41 years of hydrologic data. The scenarios modeled were the existing conditions baseline, which was the state of the structures and systems in 2017, a 2026 scenario based on the implementation of the 2018 Integrated Delivery Schedule projects, and 2 2032 scenarios, a 2032 SEP scenario and a 2032 Packer scenario that includes SEP and the EAA. The effects of sea level rise and climate change were not considered in the analysis, and projects authorized after 2018 were not included. The Greater Everglades region includes all of Florida's water conservation areas, portions of Big Cypress National Preserve, and Everglades National Park. It is a massive, low-nutrient, shallow wetland ecosystem with annual water level fluctuations driven by seasonal rainfall patterns. It includes a unique mosaic of interconnected freshwater wetlands differentiated by subtle changes in soil elevation that in turn affect hydrology. Before I go through the indicators used in the report, I wanted to show you a big picture comparison of the 4 scenarios as they relate to the Greater Everglades. The red line shown on the map to the right is a term referring to the northern edge of WCAs 1, 2, and 3. The quantity of water flowing across the red line is considered the total inflow into the Greater Everglades region. This graph shows the total acre-feet of water flowing across the red line for each of the modeled scenarios averaged over 41 years. The baseline condition scenario averaged about 1.5 million total acre-feet across the red line. The 2026 scenario increased total flows by 12,500 acre-feet, and the 2032 SEP and 2032 Packer scenarios increased average flows by an additional 220 and 350,000 acre-feet respectively. So the greatest increase in average total flows was observed in the 2032 Packer scenario. Here are the ecological indicators used in the 2020 IGIT for the Greater Everglades region. In the following slides, I will be reviewing results for the spatial extent of vegetation communities, marl prairie, tree islands, aquatic fauna, and alligators. To assess the spatial extent of vegetation communities, the Everglades Landscape Vegetation Succession, or ELVS model, was used to forecast the spatial extent and location of vegetation communities across the scenarios. These panels show the results from an average hydrologic year. The existing conditions baseline scenario in the top right is compared to the 2032 Packer scenario in the lower left, and the differences between the 2 outputs are shown in green on the lower right. Overall, we observed a transition from open marsh to sawgrass in southern WCA 3A along the L67 canal, which is indicated by the blue arrow. This transition is consistent with expectations that increased connectivity from restoration or reduced ponding in southern WCA 3A, an area which has been chronically overwetted. The short hydroperiod marl prairies adjacent to Shark River Slough and Taylor Slough are habitat of the endangered Cape Sable seaside sparrow. The sparrow's dependence on the short hydroperiod marl prairies make it an excellent indicator for marl prairie conditions. The Marl Prairie Ecological Planning Tool was used to simulate hydrologic suitability of marl prairie habitat based on sparrow survey data. These maps show the percent change from existing conditions for the 2026 and both 2032 scenarios, overlaid with areas critical to the Cape Sable seaside sparrow. We found that increased flows to northeast Shark River Slough resulted in a decrease in marl prairie habitat suitability in the eastern marl prairies. This pattern became more pronounced as restoration scenarios advanced from 2026 to 2032. In the western marl prairies and in the areas of subpopulation A, marl prairie habitat suitability increased. Overall, when comparing scenarios to existing conditions, most of the critical habitat remained unchanged. Both the 2026 and 2032 SEP scenarios resulted in a gain of critical habitat, whereas the 2032 Pecker scenario resulted in a minimal loss of critical habitat. This decrease in suitable habitat is not too concerning, as the 2032 Packer percent change map, shown on the bottom right, shows an increase in acreage outside of the critical habitat areas, which is not represented in our analysis. The Tree Island Performance Indicator compares mapped elevations of 387 of the largest tree islands in WCA 3A, 3B, and Everglades National Park over the 41-year hydrologic dataset. This figure shows the tree islands mapped and the number of days each was inundated from 2016 to 2017. The target condition of tree islands was similar to those observed in central WCA 3A, a high density of tree islands where 50% are inundated for less than 10% of the 41-year period, with the remaining having an even distribution of more frequent inundation. The existing conditions baseline, 2026, 2032 SEP, and 2032 Packer scenarios increased the proportion of tree islands that were inundated for less than 10% of the period of record when compared to the observed conditions since 1991. The most significant changes were observed to occur in the central portion of WCA 3A, the southern portion of WCA 3A and 3B, and the L29 gap area in WCA 3A. Inundation of tree islands in Everglades National Park was virtually unchanged in any of the scenarios, and northern WCA 3A contains so few remaining tree islands that only small differences in tree island inundation are possible. To evaluate aquatic fauna, we used a prey-based freshwater fish density model to estimate densities of fish smaller than 8 centimeters. Small fish have short generation times, and their abundance responds to hydrologic management at an annual timescale. This graph shows the percent change in total fish density from the existing conditions baseline for the 2026, 2032 SEP, and 2032 Packer scenarios over the 41-year evaluation period. Overall, average small fish densities decreased in 2026 scenario and increased in the 2032 scenarios. A closer look at the 2032 scenarios in an average year shows contrasting responses in northern and southern WCA 3A. These maps show fish densities for the 2032 SEP and 2032 Packer scenarios compared to the existing baseline condition. The green and blue dots show increasing fish densities, and the orange and red dots show decreasing densities. As hydrologic restoration continues, the areas that experience chronic inundation in southern WCA 3A will no longer hold as much water, resulting in a decrease in fish densities. Contrastingly, the additional water flowing across the red line in both 2032 scenarios rehydrates northern WCA 3A and predicted fish densities increase. Similarly, fish densities are also increasing in Shark River Slough as more water flows from 3A into the Everglades National Park. To evaluate predicted alligator response, we used the Alligator Production Suitability Index Model ecological planning tool, which estimates habitat suitability for 5 components of alligator production: land cover suitability, breeding potential, courtship and mating, nest building, and egg incubation. The alligator HSI was run for each scenario, and this graph shows the percent change in the HSI for the 2026 and both 2032 scenarios compared to the existing baseline condition. Overall, we observed small increases in suitability in the 2032 SEP and 2032 Packer scenarios, and a slight decrease in the 2026 scenario. A closer look at the spatial results of the alligator HSI show contrasting responses within the same WCA. This figure shows the difference in alligator habitat suitability between the 2032 Packer scenario and existing conditions for an average hydrologic year. The increase in HSI in northern WCA 3A, indicated by the blue arrow, shows the benefit of rehydrating a chronically dry region. Contrastingly, a decrease in the HSI in southern 3A is presumably from adding water to an already inundated area. The IGIT modeling exercise indicates that progress can be made in the Greater Everglades, but without additional freshwater flowing across that red line, the regional benefits observed in our analyses were limited. The 2032 scenarios predicted benefits to several indicators in the Greater Everglades, showing that with additional water and appropriate management, we can achieve progress toward a restored system. The next steps for refining the IGIT include expanding the spatial extent to include the Western Everglades. This will be important as future CERT projects are implemented, like WERP and the Picayune Strand. We should also review our current evaluation methods and update them with the best available science, if possible. And lastly, we need to include the anticipated effects of climate change and sea level rise in future IGIT efforts to better understand how CERP will be impacted. And with that, thank you for attending my presentation. You can access the 2020 Interim Goals and Interim Targets report at the URL listed on the slide. And you can also contact me with my email address provided below. At this time, if anyone has any questions, I would be happy to provide an answer. And if I don't have an answer for you, I can direct you to someone who will. Thanks again.
Okay, thank you, Tasso. Do we have any questions? I don't see any in the chat. Does anyone have any questions they would like to ask? Okay, we're actually running a little bit ahead of schedule. I'm going to suggest we just go on. Does anyone, last call for questions. And Tasso's pointing out that if anyone has any questions, he'll be listening in and, just put them in the chat and he'll be happy to answer them or discuss them at the end. Okay, we just got one from Jed. He's asking, Tasso, do you have a sense of how much water was flowing past the red line in the interim goals, interim target scenarios? Here, putting you on the spot.
Hey, Jed, thanks for the question. Yeah, I think in the beginning of my presentation, I referred to a graph. I don't know if they can pull it up again, but I believe the existing baselines condition was about 1.5 million acre feet per year on average flowing across the line. And then the 2026 scenario was an additional 12,500 acre feet per year. And then the 2032 SEP was, I think, 100,000 acre feet. And then the 2032 Packer scenario was 350,000 additional acre feet across the red line per year. So I think you can Yeah, if you can get back to that slide, that would give a great visual for it. But those are the numbers just off the top of my head.
Yeah,
So
they
six-
unfortunately can't rewind the video. So
It's all good.
yeah.
But it sounds like those are significant and meaningful shifts associated with the three scenarios, and that,
Yeah.
as you indicated, that seemed to really drive the response of the system.
Yeah, the biggest
Right,
change, is with the Packer scenario.
Cool. Thanks for. It's hard for me to keep those specific figures, numbers in mind as well. So I appreciate you revisiting them. Just because that was the connection I wanted to make. Is just that the explicit volumes and connecting that to the observed response we saw in the subsequent slides.
Yeah, that's why you saw the contrast of kind of limited benefits in 2026 versus kind of the observed benefits in the 2032 scenarios. Just because, I mean, you had an additional 200,000 and 300,000 acre feet going across that red line. Gives the managers a lot more to work with, and then you actually see some of those benefits. So yeah, that's a good point. Thanks for bringing that up, Jed.
Thanks.
Okay.
I think it's time for the next one.
Yep, we're going to move on to the next talk. Excellent.